Hello again, this is Phil Parker, and up to this point we've seen how unsupervised machine learning has been quite useful in synthesizing data and boiling things down. But there's also another very important application to unsupervised machine learning. If we're able to, for example, identify key variables that load on certain factors, and we extract those variables, we can use them to predict, therefore, something at supervised machine learning phases of the project. And that's what I'd like to illustrate with the case study of ABB. ABB is a company that is the result of the merger of a Swedish and Swiss company, Azeo Brown Boveri. And those two companies joined together in the field of electrical and industrial engineering. And the study that I'm about to share with you, published by Dennis Gench and his co-authors, describes how they use these machine learning tools to actually help this industrial engineering company. Now, this might be one of the least likely cases you would ever find where someone would use machine learning tools. In fact, it's rather counterintuitive given the situation. The product category we're talking about are power transformers. Think of a power transformer as a box. There's some wires going in and some wires going out. It's a B2B service sales engagement. An electrical engineer is selling to an electrical engineer. So what I'd like to do now is describe to you how it was applied in this non-consumer oriented application area. Okay, the story goes back to really World War II. The United States economy was booming after World War II, and the demand for power consumption was extremely high and growing very rapidly. The United States maybe represented up to 20 to 30% of the world's power consumption at that point. The market was booming. Companies were selling power transformers. Business was good. Then something happened. The first oil shock, 1973, carrying into 74 and 75, and the demand for power transformers plummeted by 50%. In most businesses, if sales grow maybe 1 or 2%, that's a bad situation. Declining 50%, that's the equivalent of the COVID crisis, for example. And what's odd about this business is electric utilities, the buyers of these transformers, they anticipate future growth going up over time. And as they anticipate future growth, they pre-order transformers, meaning the sales cycle is quite long. Well, that led to an overcapacity of transformers. Knowing the demand for power consumption was going to plummet, we had an excess capacity of transformers. This was a really bad situation. It gets worse. Poor ABB Electric, part of now the ABB group, entered the market in 1970, right before the market collapses. It gets worse. Their competitors included General Electric, Westinghouse, and McGraw Edison. These were kind of the founders of the American electrical grid, so to speak. And during a short period, their market shares were actually dipping down during a period when the market was collapsing, kind of like a bad case of diarrhea. At that point, people started considering what they should do. Well, there was a number of options. One was that they should start a price war, but the products were so mature and customers were so sophisticated that that would really not get very far and other people would retaliate. And a study at the time had revealed that there were really too many companies in this sector. Somebody had to go. Now, if you think about it, at this stage, you're just employed by ABB Electric and someone asks you, what in the world should you do? Knowing that only one company is likely to survive maybe a second smaller competitor. Your typical executives will debate and say, man, maybe they should differentiate and go into another business area. Maybe they should exit the market. Maybe they should vertically integrate. They should do some fancy strategic move. In other words, your typical executive jumps to strategic options. The first thing that pops into their minds is not necessarily, let's use machine learning to solve this problem. That's usually the last thing on the minds of most executives. So this case is going to illustrate the application of these tools at a moment in history where, frankly, there was almost no hope for this company, especially knowing that you can't simply dress up a transformer to make it look better. The people you're selling to are electrical engineers. You are an electrical engineer, and some of those people you're selling to are former employees of your competitors like General Electric. This is a tough market to crack. So, what was the board considering at that time in their history? Before going to the different options you might want to pursue, remember in the 5-step process, you should start with objectives. So going back to Europe and the European headquarters and asking the C-suite, hey, what do you want to achieve in the United States? You get a response that may be surprising. The United States is 20 to 30% of the world's power consumption. Your job is to dominate the world power market. Well, electrical engineering market. The world, that's all countries in theory. Well, all countries includes the United States, and because it's such a big piece of the world, you cannot simply ignore the United States. So, number one, dominate the United States. Two, if there's only one company that's going to be around, which company should it be? Well, it should be us. Therefore, your objective is to take out GE, Westinghouse, McGraw Edison, and everybody else in that segment as well. We want to dominate it, but we have a problem. Cash is a little bit tight right now, so we want our market shares to go up every period while you do it, but also we want the profitability of ABB Electric to go up as well. Okay, fine. Now we have the objectives. Go back to the management team and look at the things they were debating. That will tell us if they were coming close to a reasonable solution. Okay, so what were they debating? A few options. Option number one, start a price war. Just go after GE and try to take them out of the market. Unfortunately, competitors might fight back, and that kind of leads to long-run death, and it certainly doesn't increase our profitability. Another thing we could do is simply do nothing. Hope things get better. The only problem with that idea is that our market shares are kind of declining, so maybe this isn't a good time to do nothing, because that will also lead to death as our shares continue to decline. We could also just exit. The problem with exiting is that that doesn't meet the objective. So here's what the C-suite of ABB Electric decided to do. Literally at the president's level, decided to, let's implement a 3-page questionnaire. Let's get some data. Let's understand why people choose transformers from one competitor to another. Now that is a psychological breakthrough. Most electrical engineers think they know what electrical engineers think. In this case, you have to suspend your belief and say, you know, let's see if our hypotheses are correct, our assumptions are correct. Let's try to understand what electrical engineers really think. So they implemented a 3-page questionnaire. What were the 3 pages? On page 1, basically these are segmentation questions. You want to ask electric utilities, what makes your electric utility different from another electric utility? And there might be things like, how many employees do you have? Who did you last buy from? Who did you buy from before that? And who did you buy from before that and before that and before that? Of course, that type of question gives you a metric of loyalty. What time of year do you buy? Literally only 1 page. You might ask, what are your capacity plans? What is your growth expansion in the future? When have things gone badly for you, etc. So page 1, very simply, we're trying to understand what makes one utility different from another. We might use that later in a cluster analysis, for example. Page 2. These are simple semantic scale questions. You get a focus group together of a bunch of electrical engineers, and you ask them, what makes one power transformer different from another power transformer? And they're going to brainstorm. They're going to say things like, I don't know, warranty, maybe price, service, reliability, efficiency. They're going to come up with maybe 20 things. Now, we know from our previous discussions that a lot of those things will be highly correlated to each other, especially if we ask people how important these are to your decision making, where 1 is not very important and 5 is very important. Importance. Now, it's classic that a client or a buyer will tell you something that is maybe not so truthful. For example, they might say, price is everything. It's all about price. Well, maybe it isn't all about price. We know that people lie when they fill out questionnaires. Maybe after we do an analysis of these answers, we can find out that maybe some of these variables are correlated to each other, and maybe price isn't the only factor that matters. Page 3. This is a little bit different. This is really where the rubber hits the road, so to speak. I'm taking the same attributes from the focus group, I'm copying them onto page 3, and I'm saying, how different is ABB, or how good or bad is ABB on a scale of 1 to 5? 1 is bad, 5 is really good on warranty. How about GE? How about Westinghouse? How about McGraw Edison? And I do the same thing for price, and I do the same thing for the other attributes in the questionnaire. This is giving me, in essence, a positioning on one hoteling beach. On one dimension, I'm finding out where the different brands fall on that beach. That's a 3-page questionnaire. That's all you need to ask. Response rates will be extremely high, maybe up to 70% for such questionnaires. Why? Because how often are pump buyers asked about their opinions for next generation pumps? Especially in B2B environments, business to business environments. When you walk up to someone and say, hey, I would like you to help me create the next generation power transformer, likely they'll say, yeah, that's kind of cool. I'd like to participate in that. And they'll answer these types of questionnaires. Usually the data collection phase is about $20 per questionnaire. It's literally the analyst time that uses most of the budget up, not the data collection phase. And in fact, you can do this online very easily as well with an online questionnaire system. So the technology to collect the data is rather trivial. The question then becomes, what can I learn from these data? And that's where ABB literally discovered a new area in business, making this case rather historic in the field of machine learning, especially with respect to business strategy. All right, so what did ABB learn? Well, up to this point in history, they had always segmented the market by size of customer, large, medium, and small. Many industrial companies do that. And that makes sense because if you're going to concentrate your salespeople, you want to make sure that they go after the prize, so to speak, right? Unfortunately, the analysis done by ABB revealed something. Using a simple factor analysis and a little bit of logit modeling as a supervised machine learning tool, they discovered, in fact, there were 4 segments, and those 4 segments were kind of independent from the size of the customer. Those 4 segments were what? Let's think of the first one as a map, loyal to ABB. In other words, ABB is near, let's call it the ideal of what that organization would likely buy from. The probabilities are extremely high they would buy from ABB. Let's call that loyal ABB. The second segment, loyal to ABB, but switchable. In other words, there might be another competitor like GE that's not too far away on that perceptual map. The next segment is loyal to the competitor. This means that, let's say, GE has the highest probability of being purchased and everybody else is very far away. And that would be a GE loyal customer. And finally, we've got the loyal to GE, but ABB is not too far away. There might be a play there. Okay, perfect. 4 different maps, 4 different clusters of companies that could potentially buy my transformers. Perfect. Then you do what? You match those maps into your sales force data, your fixed cost structure. So imagine I have 100% of salespeople, and I simply mapped who was visiting whom. What you might discover in many business-to-business applications is the following. Most of the salespeople are visiting the loyal customers. Let's say it's something like 80, 10, 5, and 5. Most of them are visiting loyal customers. Now, why is that? Why would salespeople visit loyal customers? Because salespeople are smart. How many of you would like to earn a lot of money and not do any work? And even better, you get to go play golfing and maybe have some good food at the same time. So salespeople are smart. They're going to actually visit people who are going to buy from them. It's not that much effort. If I wanted to reallocate the sales force, I might reallocate it by giving, I'm not sure, let's say 40% to the loyal, maybe 10% to the loyal but switchable. That gives me about 50% left over, so maybe 5% to the loyal competitor and 45% to the loyal to competitor but switchable. Now, what you've just done is created a sales force revolt. The sales force will hate you. Why? You're asking people to visit customers who are not going to likely buy from you, and they will be upset by this, especially if the sales force is, one, not controlled, i.e. the salespeople are simply incentivized to sell and they get to decide what they do with their own time. That could be a problem. Or 2, even worse, it might be that you not only created revolt, but you don't meet the objective. What was the objective? Take out General Electric. So it may be that the optimal allocation in this case is to go for the jugular vein. In other words, you're going to reallocate none, maybe only 5 to your loyal ABB, just because the data might be dirty. 5 to the loyal but switchable, maybe 5 to the competitor loyal, and then maybe 85% for the loyal to the competitor. Go for the jugular vein. You do that, and all of a sudden you're targeting the segment or the cluster that's most likely to give you revenue growth. Quite insightful. Now, at the time of implementation, when you're actually going to get this on the ground, get this started, you're going to notice that a certain group of your salespeople are going to resist this change. Nobody will want to do this. Let's say it's the East Coast people. Those folks don't want to follow. The West Coast people do, just as an illustration. Okay, the West Coast people saying, you know, we should follow this because if we don't do this, we're going bankrupt anyway. And you're going to convince them to follow along in this new strategy. But they're going to ask you, we can't just keep doing what we've always been doing because it's not going to improve things. We're not going to be able to grow substantially in the West Coast area. So what ABB did is they discovered something in their factor analysis, that many of the variables were highly correlated to each other. And in fact, they found about 8 to 10 independent factors that actually influenced people's perceptions of the different competitors. So one of those key factors was the cost of owning, what today we call TCO, total cost of owning. It's often illustrated by consulting firms as an iceberg. There's a small tip of the iceberg above the water, but the cost of owning is below the water. That type of logic is not sold to a procurement department. It's sold to the C-suite, to somebody like a CFO who wants to maintain or minimize their ownership cost, the cost of operations. So they came up with this idea of total cost of ownership. Now that's intriguing because in order to minimize the cost of owning to the buyer, they had to create a 5-year warranty rather than a 1-year warranty, meaning that they will be doing the servicing of these transformers, basically asking the utilities to outsource that to them, because ABB might have economies in servicing. Their cost structures go down as they service more, especially because they're going to invest in R&D, mostly D, development, to make sure the transformers don't break over a 5-year period, improving the bolts, the doors, the connectors, whatever they can to make sure this transformer doesn't break. Now, there will be regional differences why things go wrong. In places where there's ice storms, it may be very different than in places where there might be a hurricane or maybe an earthquake. So you might have to modify the things you do when you sell to different customers as you go to market with this idea. So in essence, you say, I'm not going to sell you a transformer, I'm going to sell you a service. So you create a service package. And by doing so, you make price a non-issue. Now, in industrial marketing, B2B marketing, the way you make price a non-issue is that you actually sometimes have to risk being thrown out of a competition. You all know that you have an RFQ or an RFP, some kind of tender you have to respond to, right? If you do not follow the recommendations or the outline of how the tender should proceed, you will be rejected from the competition. Well, ABB, knowing that total cost of owning was the most important thing, decided to show graphically, what it is that made the cost of owning their transformers lower than competitors' products, even though their products were perhaps at a higher price, by perhaps illustrating all the things that go into the abased price and even admitting, so to speak, that their price is higher than GE, Westinghouse and McGraw Edison. But below that abased price, of course, you can add all of the things involved in the ownership and cost of operating a transformer. What would be those things? Just things like general maintenance, staff, connectors, paint, whatever it is, all of those things go below the abased price. So yes, ABB is more expensive, but we have a lower total cost of owning. ABB implemented this strategy. They reallocated to the switchables, of course, and created kind of an online system of sorts that allowed the salespeople, when they went to a particular client, to literally say, hey, here's what I think you should sell. Here are the key selling factors you should look into. Now, this paper won the Endelman Prize, very prestigious prize in management science, because it was implemented and ultimately published in a journal called Interfaces. So let me tell you the outcome of this Interfaces article. It was documented in a videotape at an awards ceremony. So if we turn to that right now, we'll get to see what exactly happened. What happened? We'll get to see. So if we turn to that document now, we can see what happened. Okay, as you can see in the very first figure, the market was actually growing quite substantially for transformers, but then you can see that collapse occurred and the market was going to stay low for a decade thereafter. So the picture doesn't look good. Things are not going well right now in the transformer market. Then ABB implements its switchables idea and the 5-year warranty. Let's see what happened there. If you look at the evolution of their market shares over time, you could see that it went up to about 6% and then flattened. Then they implemented the 5-year warranty. Once their sales force started applying the choice modeling process, then all of a sudden they were targeting the switchables. Now, the entire sales force maybe not have been doing this, but at least enough where you could see empirically that the results were coming in. This choice modeling is a way of saying we took factor analysis, found the independent factors that had some influence on the choices between different transformer suppliers, and then we used them to predict the probability of someone switching. That's using a logit curve or a logit model. So again, unsupervised machine learning tools were used as independent variables to forecast probability of switching across different transformer buyers. Eventually they got about 40% market share by the year 1988. It grew after that as well. And on a table a little bit higher on the same page, we get to see the results of what happened. If you look at the evolution of competition in this market, many companies left the market. Since ABB had entered in 1970, 6 transformer manufacturers had left the industry completely. It's very interesting to note in the year 1986, GE closed its Pittsfield, Massachusetts plant. And that's a very interesting data point for me personally. I was doing a training program for McKinsey & Company at a place called Williams College, a beautiful campus in the middle of Massachusetts. I arrived at the airport in New York and was driving across Massachusetts to go there. And I like talking to the cab driver. I'm the kind of person you definitely do not want to sit next to in an airplane. I'm the guy who talks to you. I find out, what's your objective? Why are you going there? I do an audit on you. I'm allocating your sales force by the end. Anyway, I'm talking to the cab driver, the taxi cab driver, and he's telling me which stocks to buy and sell on the stock market. I'm going, man, you are totally sharp. Do you own this cab company? Like, how long have you been driving this cab? And he goes, well, actually, it's only been a few years now. And I go, really, what did you do before that? And he goes, well, I was an electrical engineer. And I go, really? You were an electrical engineer? Why the career change? He goes, well, I used to work in Pittsfield, Massachusetts, making transformers for General Electric. And then this European company came into the market with a high price and basically, like a cancer, ate us alive. And I thought that was a very interesting thing, that GE did not respond necessarily to this threat in the way one might think they would. They actually kind of lowered their price, and actually total cost of ownership for GE products remained extremely high. And eventually they exited the market because maybe the transformer market was not seen as a great investment in a conglomerate that had many investment alternatives. At the end of this process of doing this analysis, ABB was given this famous award I mentioned, the Endelman Prize, and the CEO and many of the marketing people and production people presented it on a video, and the CEO said a few pearls of wisdom. The first one was, many people were skeptical of using these new statistical tools to make decisions. So I escalated the application of these tools to the C-suite. To the C-suite. So if I didn't take it seriously, I don't think anyone else will. Many times, data analytics are too far down the organization to have impact on strategy. So he escalated it. Second, he said, I actually watched and looked at the questionnaires coming back. I wanted to see the reaction of the customers, and I wanted to know the database a little bit. So becoming engaged in the data is quite useful. Third, he said that meetings were a lot shorter once they had the data. Before they had the data, everybody was debating about what ABB should do. Once they had the data, it became very clear. And the last thing was, he said it really motivated everyone in the organization. Everyone was excited because there was some basis for them moving forward. They knew what they were after. And they said it was fun beating up on General Electric. So again, this is a nice little case of doing simple survey data. Not doing data mining on your own data warehouse, going out and getting data of your non-customers just as much as you get data on your own customers. Many companies collect customer satisfaction questionnaires. This is largely irrelevant to machine learning applications and business strategy. And the reason is very simple. The human mind doesn't only look at your product. The human mind looks at competitors out there. So if you want to have an algorithm that mimics human behavior, that can simulate the choice of humans, don't ask, how was the service that you just had in this airplane or at this hotel or at this restaurant? Instead, the right question is, how different do you perceive the service you just got compared to the service you would get from competitors? Now I'm starting to evaluate really the basis of competition. And from there, I can perform factor analyses and cluster analyses, use them as independent variables into a choice model or a logit model or a logistics curve, and then estimate the probabilities of one customer switching to another. One of the things you should ask yourself is, do I have a database in my company, in my data warehouse, which has all of the potential customers I could ever sell to, and then list the probabilities of them switching? Who would they switch to, and on what basis they would switch? If you don't have that type of data, get that data. Now, many people may not have the resources to do such an analysis. They might outsource it to a consulting firm. My advice is the following. Take the ABB article that I've listed here in the citations. Take this ABB article, go to a firm and say, can you do this? If they cannot, then you don't have a management science firm you're talking to. It's largely a polling company, a company that does survey research. So what I highly recommend is take this article, walk into an organization and say, can you do this? This article, as you see, is not brand new. This technology has been around a long time, and many people have been able to replicate the ABB success story. The reason it's so impactful is, in my field, this is famous. This started the ball rolling, showing people that you can use very simple analytics to derive extremely impactful results. Take care, everybody. Bye-bye.